So let's look at when the object is moving in uniform acceleration. So this was a case of non-uniform or zero acceleration actually. This was a case of zero acceleration. So the velocity is flat, the distance and displacement have a positive slope, and done. Now let's make the object move with some kind of accelerated motion. So when an object is accelerated, what is that we are looking at? We are looking at it going with unequal distance. And the amount of distance it increases, that is constant. That we have shown in one of the videos, I forgot which, but we have discussed before. So I've shown exclusively that the distance being covered, it's kind of linear. The extra bit of distance that is covering, it's linear. So all of that you guys have to, again, my classes goes from end to end. So I mash up all the topics, I keep giving hints. So all the theory part you guys can't miss. Numericals, if it's easy, you can miss. But theory part, my suggestion is don't miss them. If you're good with numericals, that's good. Then if you feel something is easy, it's okay. So all this for example of constant velocity. So let me clear this up. Now we are looking at non-constant velocity. So when it comes to your velocity time graph, we have displacement time graph, velocity time graph. So this is a line which can be something like this. It can be something like that, or even this. So you can see that the slopes are fixed. Slopes are fixed of any combination of points that you take on the line. Okay, so the slopes are fixed. When it comes to your displacement time graph, there are many possibilities. This is one of them. It can look something like this. It can look something like this. Over here, so on and so forth. So here I'll take up 2 points and let's analyze them. So for this run, right, say till here, this is the rise. For this run, this is the rise. So if I copy this and check different point, can you see that? It won't match. It won't match. It clearly will, it's not matching. So here also it's not matching. So only at a particular point it's matching. Somewhere here, I guess. Right? While over here, if I happen to, okay, no, not able to. Oh yeah, kind of matching. So for this entire line, I'm able to match this. I hope it's very visible. It's very light. Okay, guys. So here the slopes are not the same. It changes at every point. So let me cancel this and show you guys the same. Can you see that? So it's not as dramatic as mine, but you can see the bend in displacement time graph. While in velocity time graph, you can see there is a positive slope. Again, it can be negative slope, it can be positive slope, it can be in any quadrant. So there are many possibilities. Now we are looking at acceleration time graph. Since we are looking at a uniform acceleration, means what? The change in velocity is constant, means the acceleration is a flat line. It's parallel to x-axis. So all these are parallel to x-axis. So it can be a positive line, it can be a negative line. The slopes are zero though. The slopes are zero. Please understand the slope concept, the values. You need to understand every aspect of a line and not get confused. You are in that grade that you should not be getting confused over here. Okay, then what else? So you can see it over here. We have 20 throughout. And what else? Okay, so parabola bending upward, but why? Parabola bending downward, but why? So we have a parabola bending upward. Means what? Every moment of time, the distance being covered, it's increasing. Parabola bending downward, it would be something like this. So let me show that as well. I'm decelerating the object and then making it move in the opposite direction. So it's decelerating, the turtle is decelerating and it's going back. Now let's have a look at the graph. So can you see that? It's increasing, then it start decreasing, and you can see the opposite is happening. Of course, the time is moving forward, that is there. And we have the velocity to be negative from somewhere over here. But it's decreasing, that is there. And the acceleration is clearly a negative value. So this is your parabola bending down. So why is it bending down more and more? Means every second it is moving more to the left. So it's an accelerated motion.